linear equations. A linear equation is an equation whose solution follows a line on the coordinate plane. So linear equations shows the relation between x and y values of a line. So let me show it on a graph. Let's see, that's a line. As you see, okay, that's a good line. Now let's think about this point. This D, you can move any point on the line. So for any x value, I'm going to get a y value. For example, when x is 3, y is 2. When you get x is 4, y has another value. So when you move the x value here, as you see that side, and you will see y values change relatively to the x one. So the equation shows this relation we call a linear equation. Why? It shows the x and y value, change of the x and y value on the line. So as you see, my point all time on the line, it's moving, and the x value and y value changing according to this point. If you change the line, now this is not the same line. So let's change that way. Okay. And when you move the point again, for any x value, you will have another y value. For example, x is negative 2, y is 2.9. Or here x is 1, y is 1, or 0.9. So when you change x value here, as you see, when you change the x value, so the y value is changing with it. The equation shows this relation we call linear equation. So a linear equation, when you solve a linear equation, the result becomes line. So the linear equation shows the relation between x and y value on the line. Okay, let's continue. Y equal to x minus 1. As you see, that's a linear equation. Let's continue. Y equal to x minus 1. So there is a relation between y and x here, as you see. Y and x. We have a relation between y and x. What is this relation? Y all the time is equal 2 times x minus 1. So how can I decide that's a linear equation or not? You can check the power of x and y. If the power is x and y, so power of y and x is 1, so it's not written as a power, we call it's a linear equation. We know it surely. But let's show that it's really a linear equation. How? We can draw a table. So we will randomly give an x value. According to this x value, we are going to write relation y equal 2 times x minus 1. So I'm going to find a y value for my x value. Then I'm going to write an ordered pair x and y to locate it on the coordinate plane. So let's try with 2. If x is 2, so y equal 2 times 2 minus 1. So 2 times 2, 4, minus 1 is 3. So when my x value is 2, my value is 3. 2 and 3. So let's check y is 1. Y equal 2 times 1 minus 1. 2 times 1, 2 minus 1 is 1. That's good. 1 and 1. Let's check 0. Actually, if you are sure about this linear equation, from 2 points, you can draw a line. But to be sure, I will write here 4 or 5 points, 4 or 5 different x value. So if x is 0, so y equal 2 times 0 this time, because x is 0, minus 1, that's negative 1. So it's going to be negative 1 on the y. Then let's try minus 1. Y equal 2 times minus 1, minus 1. 2 times negative 1 is negative 2. Minus 1 is negative 3. So minus 1 is negative 3. Let's use 2, negative 2, sorry, we already used 2. Y equal 2 times negative 2 minus 1. 2 times negative 2, negative 4, minus 1, negative 5. So my ordered pair, x is negative 2, y is negative 5. Don't forget, when you write ordered pair, all time first value x, the second value is y. Let's locate this point. 2 and 3. 2 is here, and 3 is here. Then 1 and 1. 1 and x is 1, y is 1. X is 1, y is 1, so that's the point. And let's continue. 0 and negative 1. 0 is here, negative 1 is here. And minus 1, minus 3. Minus 1 and negative 3. -2 and -5, -2 and -5. These are the points. When you connect these points, so it's going to be a line. Let's draw a line here if it's possible. Yes, that one. Okay. I think if I start from here, it's going to pass through that. Sorry, my bad. Okay, that's good. As you see, from all these points, we can call them collinear points there on the line. So if I use the decimal points, so that will be, you can fill all this line with the points. So solution of y equal to x minus 1 is this. Don't forget, line doesn't have an end point, so they continue. For any x value here, you will find a y value. That's the linear equation. Two things you need to know. First, how to graph. You give x values. According to the x value, you will find y values, and you will put points on the graph coordinate plane. And you can decide it without, if it's linear or not, you can decide without drawing a graph. You can check the power of y and power of x. So if the power is 1, so there is nothing written as a power, we call it linear equation. Let's see y equal x squared. So as I can say directly, that's x squared, so it's not linear. Let's draw it. How can we draw it? Actually, you can draw the same way. You can write x, y equal x squared, and you can say y value, then x and y ordered pair. Sorry, that wasn't good enough, right? The ordered pair of x and y. So I'm going to give to a 5 value again, 2, so y equal 2 squared. Don't forget, when you substitute an x, you use parentheses because power is matter here. So 2 squared is 4. 2 and 4 is the first point. 1, y equal 1 squared. 1 squared is 1, so 1 and 1. Now 0, y equal 0 squared, then 0. 0 is going to be 0. So origin, that's the point of origin. -1, here be careful now. Y equal -1 squared. -1 squared. So don't forget, you will need to substitute 1 instead of x. So this use parentheses is important, using parentheses here. -1 squared is 1. So my point -1 and 1. So let's use -2. Y equal -2 squared. -2 squared is 4. Positive 4, don't forget, -2 and 4. Let's look at these points. First point 2 and 4 here, 1 and 1. The origin is 0, -1 and 1. -2 is going to be 4 again. As you see, that's not linear. So when you connect this point, near something's going to be like that and goes from up. I couldn't draw it perfectly, sorry. So let me show you on the application, it will be better for us. Okay, now I wrote a function here. You can see x squared, so this y value going to be x squared. Let's locate our points here. 1 and 1, that's 2 and 4, and -1 squared is 1, 0 is 0, -2 squared is 4, and as you see, that's parabol pass through my points. So I can continue 3 squared. 3 squared is going to be, let me check, where is it? Go a little down, yes, that's better now. If you continue 3 squared is 9, and -3 squared is 9, as you see, any square number. So this line, any point on this line, it has a square of a value here. So square of a value here, square of a value here. Any point on this line, it's a squared number, but it's not a line. As you see, it's a parabolic shape. So from the application that I showed, my draw is not perfect. Still you can say y equal x squared is not a linear equation. Why? When there is a power, not linear equation. That's all. So two things we learned. What is a linear equation? How we decide it's linear or not by checking the power of x and y, and how we draw what is not linear equation, how it looks like. At least I showed the simplest one, y equal x squared. Thanks for listening.